So this is my second time. Today we learn how to solve polynomial with higher degree or power. Example number one, we have f of x equal x to the 4 powers minus 144. So we know that the degree is 4. So we expect to have 4 solutions. So whatever the degree of the functions is, you have to have that many solutions. To solve these functions, we need to set x to the 4 minus 144 equal to 0. I'm going to isolate the x to the 4 and move 144 to the right. I have positive 144. And then I'm going to take the 4 root of the x to the 4. So those two cancel out. I'm going to have the x. Using calculator, I'm taking the 4 root of 144. I'm going to have 3.46. 346. So we're gonna have two solutions here because whenever we take the root, we always gonna have a positive and a negative solutions, even root. But that is the decimal solutions. To find exact solutions, we can um, just by simplifying the 144 is 12 square. Now 12 is 4 times 3. Then we're going to rewrite 12 as 4 times 3 to the second power with the 4 root on the outside. Then 4 is 2 squared. 2 times 2 with the power is 2 to the 4. So that number 4 exponent of the 2 will cancel out with the 4 root. So you're going to pull out the 2. The second power of the 3, you can cancel with the 2 on the 4. You're going to have 2 squared root of 3 plus or minus. So let's look at the graph. So here is the graph. So on the graph, you're going to have two x-intercepts. So positive 346 and negative 346. So those two are the two real solutions of the functions x to the 4 minus 144. But we have said from the beginning that there need to be, or this function is going to have four solutions. So we're missing two solutions. What happened to those two solutions? So let's solve this by factor x to the 4 minus 144 into x squared minus 12 times x squared plus 12. I am using these formulas on the bottom. Whenever you have a numbers, a square minus the b square, you can factor as 8 minus b and a plus b. So if you cannot see what I'm doing, I'm going to make x to the 4 is x to the second power times 2. So after I factor out with this factor, then I'm going to set each of the factor equal to 0. Again, I'm setting each of the factor equal to 0. Then I solve for x. So I move the negative 12 to the right, and I'm going to take the square root of the x squared. It turns into the x. When I take the square root of 12, I'm going to have plus or minus 2 square root of 3. So those are two real solutions. So on the right, I'm taking the square root of x squared, but then I have to take the square root of a negative 12. So we cannot take the square root of negative 12 with to have the real solutions. We have to convert it back into something we learned it before. That is 12, negative 12 equal to 12 times negative 1. Negative 1 is I squared, the imaginary number. Then we're going to take the square root of I squared. It's going to give you the I. Then you're going to have a plus or minus. So now those two are the two complex solutions. So we have total of four solutions now. A negative, 2 square root of 3, a positive 2 square root of 3, a negative I 2 square root of 3, and positive I square root of 3. So we have 4 solutions. Next, example number 2. Here we have x of x equal to x to the 4 minus 3x squared minus 10. So if you cannot see because you are not familiar with the power of 4, so you to make the problem a little bit easier for your eyes, you can make the lowercase x squared into the capital X. So now then the capital X squared equal to the lowercase x to the 4. Then I'm going to replace this into this equations. So instead of you have the lowercase x4 minus 3x2 second power, I'm going to have the capital X squared minus 3x minus 10. So when it looks familiar with you all now. So our job is to factor this. So we need to find the two numbers time to get negative 10. And when we add, we need to have a negative 3. Those two. So those two numbers that I found is negative 5 and positive 2. To check those two numbers, if we get it correctly, we need to multiply negative 5 and 2 to get negative 10. We're going to add negative 5 plus 2 to get negative 3. So we know those two numbers we chose or we found are correct. Then I'm going to go back in to replace the capital X into the lowercase x squared. And those are the two factors that I have. Then I'm going to solve these two factors by setting them up to equal to 0. Then I'll solve for x. I solve the x squared minus 5 by adding 5 on both sides. Then I'm going to have x squared equal to a positive 5. Then I'm going to check the square root. And the square root of x squared turn into the x. The square root of 5, we can't do anything about that. We're just going to have the plus or minus. So let's take a look on decimals to see what we have. So here we have the graph of the x squared minus 3x squared minus 10. So we have two real solutions where the x-intercepts are. So one is negative 2.23 and one is positive 2.23. So what is the square root of 5 right there? So square root of 5 is 2.23. So if we have a negative square root of 5, we're going to have negative 2.23. And those are the two real solutions. And now we need to set it up x squared plus 2 equal to 0. Then I'm going to minus 2 on both sides. So I'm going to have x squared minus equal negative 2. Then I'm going to check the square root. I'm going to get the square root of negative 2. Negative 2 then equal to positive 2 times negative 1. Negative 1 is the I square. Okay, so negative 1 is the I square. Let's put the little dot right there so you can see. Okay, so it's I square. Now the I square, the square root of I square is I. So those are the two complex solutions. Now on the graph, you only see the real solutions as I prove it to you on decimals. You don't see two complex solutions. And that's why it's so important that you know how to factor, follow all the steps to find all the solution, real solution, and also the complex solutions. So we know that this example number 2 that has a degree of 4. So the degree is 4. So you need to have 4 solutions. So let's check. We have 2 real, 2 complex solutions, a total of 4. So let's move on to example number 3. So example number 3, we have the function f of x equal x to the third minus 9 x second plus 5x minus 45. I have put this function in the order of the degree from the most to the least. So from the highest to the least, so the x to the third power, or those are the highest degree. So the degree is 3. So we know we need to have 3 solutions. So for this problem, I'm going to use the area model or the box method. I'm put all the terms from the function into the box. So again, I start by putting all the term in the box. Then I'm going to factor out the common factor. You can pause the video and think about this. Okay, so again, I'm start with putting the term inside, and then I'm going to factor this. So you can start by, like I say, you can do by just start with the box, right? So you're going to start with the box like this, and then you're going to put every single term from the function in the box. So you're going to put x3, put 9, negative 9x squared. You're going to put 5x here. Then you put negative 45 there. Now you're going to factor out the common factor from the box. So to the left, you're going to have x squared in common. On the bottom, you're going to have 5 in common. And now this one, you're going to have the x is the common factor between this. And then to this one, you're going to have a negative 9 is the common factor between those two. So now here you have the factor x minus 9 and x squared plus 5 came from the side of the box. And then like we did before, we're going to set each of this factor equal to 0. Then we solve for x. So x minus 9 equal to 0. We're going to add 9 on both sides. X equal to 9. So this is real solutions. We know that we will see these solutions on the graph. Now that's one real solutions. Then we're going to move on to the right. We need to solve x squared plus 5 equal to 0. I'm going to minus 5 on both sides and then take a square root. So x equal to plus or minus. Again, every time you solve for x when you take the square root, you need to have plus or minus. So there are two different solutions here. So negative 5 is 5 times negative 1. Negative 1 is the I square. I square square root is I. Then we're going to have two complex solutions. So whenever we have complex solutions, we cannot see it on the real number xy plane. So let me show it to you. So this is the graph. So you see it's going from the left on up, and then it's go all the way down, and then go back up again. So what is the solution here? So it's 9, 0. So you can see the real solution is 9. The x-intercept is 9, 0. So this is what we get here. So we can definitely see this on the graph. But we cannot see the two complex solutions. So how many total solutions we have for this functions? We have total of 3. One real solutions and two complex solutions. 1 plus 2 is 3. What is the degree for this function? It's 3. See you guys in the next video.